Welcome to our next video. This time we are going to another aspect of vectors, this time in 3 dimensions. Because we know that if we find the vector product of 2 vectors in 2 dimensions, the outcome will not still be a vector, but a scalar. That is why we are going into vector products using 3 dimensions so that the outcome will be a vector. You need to understand that when we have 2 vectors that are being multiplied using the cross, and we call this a cross product of vectors, the outcome is the 2 vectors a, b, sine theta. I can see where the angle theta is that angle between the 2 vectors a and b, and the vector product is perpendicular to the 2 vectors being multiplied. That is why the diagram, you can see here, we are multiplying vector A with vector B, but the outcome is perpendicular to both of them. That simply means the angle between the outcome and the 2 vectors you are multiplying becomes a right angle to the 2 vectors. That is why we call it the cross product of 2 vectors. The outcome of the cross product will give us a vector, but the outcome of the scalar product, that is always called the dot product, will always give us a scalar. Now let's find the 2. Let's take an example in multiplying these 2 vectors together and see what it will give us. Suppose we have the 2 vectors so given vector A as A sub 1 I hat plus A sub 2 j hat plus A sub 3 k hat, and then vector B as B sub 1 I hat plus B sub 2 j hat plus B sub 3 k hat. Now the product of the 2 vectors A cross B, or A times B, we are going to use determinant. So let's arrange them as the unit vectors I, j, k. Then let's have the values of A to become A sub 1, A sub 2, and A sub 3. And then have B as B sub 1, B sub 2, and B sub 3. So this should be equal to, if you pick I first, that I automatically, we are going to have nothing under I and nothing on the side of I. So we're going to have A sub 2, A sub 3, B sub 2, B sub 3. And then J will be minus because we are moving from left to right, I plus minus plus, and then from I down plus minus plus. So you're going to have minus J hat. This time you're not picking any of the elements under J and none by the side of J. So you're going to have A sub 1, A sub 3, B sub 1, B sub 3. Then K, which should be a plus now, K hat. You are going to pick nothing under K and nothing by the side of K to have A sub 1, A sub 2, B sub 1, B sub 2. So expanding this out, we are going to have I hat into A sub 2 times B sub 3 minus A sub 3 times B sub 2, then minus J hat into A sub 1 B sub 3 minus A sub 3 B sub 1, then plus K hat into A sub 1 B sub 2 minus A sub 2 B sub 1. So we are done with this. So from what we can see on the board, if we are to find the cross product of 2 vectors A and B, that is A dot A cross B, that gives us the outcome that we have here on the board. I into a sub 2 b sub 3 minus a sub 3 b sub 2 minus j into a sub 1 b sub 2 minus a sub 3 b sub 1, then plus k into a sub 1 b sub 2 minus a sub 2 b sub 1. Now we can observe that in the formula here, which is not actually a formula but an outcome of the multiplication of the two vectors to get a vector, we still have vector I hat, j hat, and k hat as the outcome. But this is different from the dot product, where the outcome does not have any vector in it. In the dot product, we only have the scalar outcome, but not a vector. But you can see for vector product, we still have a vector. And that is where the name comes from. Thank you so much for watching. Watch out for the example on this